This is Viterbi Voices, your chance to hear stories about research, classes, student life, and more.
Directly from our students, faculty, and other members of our engineering community. All right here at the USC Viterbi School of Engineering.
Welcome back into Viterbi Voices. My name is Paul Ledesma. I'm the Director of Undergraduate Admission at the USC Viterbi School of Engineering, but you already know all that because we've been issuing so many episodes lately. This is another faculty roundtable, this time with faculty from the Computer Science Department. We've got three fantastic faculty here. The chair of the department, Dr. Cyrus Shahabi, Dr. Jeffery Miller, and Dr. William Halfond, who we call GJ. Now, Cyrus, Jeff, GJ, all great guys, really cool, really focused on working with our undergraduates in addition to advancing the research of the school. This is a lot of fun. We had a lot of fun with this one. I actually burst out laughing at one point uncontrollably. I probably hit the levels on our recording a little bit too much, so I apologize for that if it blows your ears out. But this is a really cool discussion as we talk about computer science. Computer science is often misunderstood because people take programming classes in high school, so they think they know how to do it. And this talks in detail about our curriculum, the approach to that curriculum, the balance of theory and hands-on work, how it advances through capstone courses, and also where this all leads. And so sit back, relax, and enjoy the soothing sounds of our computer science faculty as they talk to you about computer science at USC and the Viterbi School of Engineering. And I hope you all are staying well, and we'll see you all real soon.
What we're going to do today is we're going to talk about the computer science department. We're going to talk about the curriculum. We're going to talk about the program in general. And in order to do that, we have some fantastic faculty members here. I'm going to let them introduce themselves. First, we'll start with Dr. Halfond, and then we'll go to Dr. Miller, and then Dr. Shahabi.
Hey, hello everyone. My name is William Halfond. I'm an associate professor in the computer science department. My research is broadly in software engineering. I teach the junior level software engineering class. I'm also the associate chair for undergraduate affairs.
Thank you. Dr. Miller.
Hi, everyone. My name is Jeff Miller, and I am a Trojan through and through. I've got my bachelor's, master's, and PhD from USC, and I'm on the faculty. I'm an associate professor of computer science practice, which is a teaching faculty role. So we don't have research responsibilities, but we teach a lot of our undergraduate classes. Specifically, I've been teaching our third programming class and our intro sequence, as well as our capstone class, which all graduating computer science students are required to take in their last 2 semesters.
Fantastic. Dr. Shahabi.
Hi, I'm Cyrus Shahabi. I'm a professor at Computer Science Department. I'm also the chair of the Computer Science Department. My research background is databases and data science, as well as recently data analytics and AI.
Fantastic. And I neglected to introduce myself. For those of you that don't know me, my name is Paul Ledesma. I'm the Director of Undergraduate Admission. I'm the least important person here. I am just moderating this conversation, and I'm happy to do so.
I thought I was the least important.
Right. So what we want to do, I think, first off, and just to prove the importance, I think we're going to start with Dr. Shahabi, but then anyone else, please jump in. Can you help explain, this sounds like a really simple question, but it's going to have a complex answer. What is computer science? And then I'll add on to that. Keep in mind, we have students that maybe have done programming, some students that have never done programming before in their life, and programming isn't necessarily computer science. So how can we explain what computer science is?
Well, you said that's a simple question?
I said it seems like a simple question. It's going to have a really
seems like it. Okay. Yeah, it is not a simple question. Let me think. I was not ready for that. But computer science as a field, I guess, if you want to define it, is basically the whole science of all the way from how you build a computer, which includes some of the hardware part of it, and that's basically our computer science, computer engineering track, all the way to building various software of the computer. And that includes things that you need for the computer to even be operational, like the operating system, the networking system, so it can connect to internet and so on, all the way to software that you build for various applications. For example, you have various data mining or artificial intelligence type software that you need to develop for applications in health, applications in transportation. For example, people these days are familiar with navigation systems like Waze or Google Map. These are all built on computer science software that are customized specifically for those applications, including mining data to, for example, predict traffic or predict what's the fastest way to go from point A to point B. Many of companies actually recently, including companies like Amazon, for example, it may sound like a warehousing logistics company, but it's really a computer science company. Uber, for example, may be considered as a ride sharing, but it's really a computer science company because they are really built on software that run on various computer systems. I don't know this was the best definition, but maybe others can help.
That was great. Any other thoughts, Jeff or GJ?
Yeah, I think think about in terms of the things you learn. We talk a lot about the different kinds of algorithms that go into computers or underpin modern computer systems, how to build those software systems, and also the applications in the real world. So how we take those algorithms and how we take the software we're building and how they're being used to solve these problems. Like Cyrus was just talking about in terms of applying machine learning and data analytics, robotics, and also building software for real stakeholders. So I think something that Jeff in the capstone course does a lot of as well.
Yeah, I think I would take a more broad picture. Cyrus mentioned some of the specific applications, but I would go a little more broad and say that nearly anything that we do nowadays touches something that a computer scientist created. Whatever that is, whether it's web or mobile or with cars or just your smart homes and kitchens and everything that we do on a daily basis, there has been a computer scientist that had something to do with development of that product.
Absolutely. So how can we help explain to our newly admitted students how the curriculum is structured? And maybe we can start with how students will be introduced to the computer science curriculum in those intro courses.
Sure, maybe I'll start with that. We have our 4 different majors within computer science. We have the course computer science. We have the CS, or the business administration. We have our CCS, which is the joint undergraduate degree with the electrical and computer engineering department. And we also have the CS Games, which is the joint degree with the cinema school. Across all 4 of those, we have essentially a core of computer science classes that students are taking in their first 2 years, or roughly. They include an introduction to a lot of the data structures and algorithms that are part of modern computing systems. We also run through a lot of the basic programming skills. So classes like 102, 103, 104, 201 are all classes that everybody's going to take. And then after those, everybody gets that core of the computing theory and also the computer programming. We start to branch into the more specialized topics like machine learning, robotics, operating systems, networks, software engineering. And there you start to see a lot more of the electives, right, where students start to either chart their course based on their personal interests or based on the requirements of one of those 4 specific majors that they've chosen.
That was great. Thank you. Let's do a little role playing. I'm going to pretend that I'm a high school student that's been programming since the age of 6. Pretty sure I know everything you just talked about, and I'd like to jump directly into those graduate level courses. You're going to allow me to do that, right?
Well, there are some placement exams that students can go through. But, I think it's actually really important that not everybody comes in knowing a lot about computer science. In fact, we have quite a few people who've never done programming in high school. And that's actually okay. We have different intro sequences that help to basically allow people to come in at the level of background they've had. And we try to just catch everybody up. So while there is potential for the people who, that small group who have lots of experience to take more advanced classes if they can qualify for them, we also have at the other end of the spectrum a lot of people, probably about a third, who have not had significant programming experience at all in high school or before. we have a sequence that enables them to get caught up and be able to access those classes. Basically, by the time they're done in their second year, they'll be at the same point where they can start taking these more advanced classes.
Absolutely.
And to add to that, for anyone who doesn't have any programming experience whatsoever, we strongly encourage you to still come through our program. That you may have a lot of classmates who have taken programming classes and you hear them talking about things that you don't understand. And our first programming class that you would take, our first CS class, is expecting you to know nothing. That's how we're expecting you to come in. And for students who know something, as GJ just mentioned here, that will actually allow you to pass out of a class and move on to another class. But our first class, we expect you to not know anything. So please don't be discouraged if you've never taken any programming class at all before coming in. Myself, as an example, had never programmed before I took the very first class at USC. And then I continued on for a couple decades now, and I'm on the faculty.
It all turned out okay. Now, on the other side of that coin, is sometimes students may come in thinking that they know more. They're probably a little more confident than they should be because they've done some online courses in programming. Can you explain the difference between taking a programming class either in high school or online, and how that compares or contrasts to being enrolled in a full computer science program at USC?
Sure. Yeah, I can go ahead and jump on that one to start. So one of the things that we provide is we have a lot of support for our introductory level classes, our 1 and 200 level courses, which are the freshman and sophomore level classes. So a lot of support from faculty, from TAs, from students who have gone through the classes already and that we hire back to help out. We call them graders or course producers, who will help all of the current students through the class. One of the big differences that you'll see is that with an online class or with watching a video or edX or any of these MOOCs that you may have gone through, is that you don't really have any other support. So you can watch videos, you can try to learn on your own, but as you're writing code, when you run into trouble, and guaranteed you all will run into trouble at some point that you're not going to be able to figure out, you're going to need some resources to turn to. And we provide a lot of those in our intro classes. Now, as time goes on and you get that foundation and you learn more, you're going to be able to figure things out on your own. However, just having all of these amazing resources that we've got available really helps out in those intro classes.
To add on to what Jeff was just saying, I teach software engineering, so it's a 300 level course, and it's quite normal for people to think that this is just advanced programming. So Jeff's class 201 is actually the prerequisite. His advanced programming class is a prerequisite for 310, which is a software engineering class that I teach. And one of the things that's very different in 310 is that it's not really any more of an advanced programming class. It's about going through the process of software engineering, which is working in groups, learning about the tools that enable groups to coordinate and collaborate on projects. It's one thing to code a small programming assignment with some loops and maybe some threads, or maybe modify an operating system kernel. It's another thing to do that when you're in a group with maybe dozens of other people and you have to coordinate these things. And that's one of the things that we focus on in my class, and then we build on again when you come to the capstone in Jeff's class.
Okay, you touched on this, and I'd like to see if we can spend a moment discussing a little more detail about the importance of collaboration and teamwork in our undergraduate curriculum. What can students expect? Because they're dealing with trying to understand competitive natures of engineering schools and kind of somewhat of our collaborative approach.
Sure, let me talk about that in the context of 310 and this is a group-based project class. So teams are given a software assignment that they have to start from the very, very, very beginning of the software engineering process, all the way with eliciting requirements, figuring out what exactly are the requirements for the software system that has to be built, doing the project planning in terms of the schedule, figuring out the resource allocations and in terms of time, moving on to things like the design, how do we coordinate using repositories and do things like continuous integration and regression testing on these large-scale software systems that are being built and deployed. So these are some of the things that any of these projects are too big for any single person. So there's no chance for a group hero to come along and solve it. The group has to figure out how to get these things done together. and use the same kind of tools and processes that people in industry are using in order to be able to get these projects done.
That was really great.
I was also, regarding your previous question, I think one distinction I want to make is that taking programming courses to just basically learn how to program, which is I guess many of the undergrads starting at USC might have that, is a little different than the courses that we have where they actually understand the concepts. So for example, I think 103, so somebody who's coming with already a programming, probably they can start with 103, which is the only course that says actually it's introduction programming is the title. But after that, like 104 is actually starting teaching concepts, like teaching the concepts of data structures, teaching the concepts of object-oriented programming. These methods and concepts are the ones that stay with you independent of what programming language you're using now. Programming languages changes. Like when I went, I'm going to age myself, but when I started, I learned Pascal, and believe it or not, I heard actually recently they were talking about COBOL being used for these unemployment processes. Yep. I know COBOL, so finally my programming skills are useful. So basically the programming language itself changes, but throughout the years, like right now we're teaching C++, soon we might switch to Python or something. But the idea is that these concepts you need to learn how to, in order to design effective programs that not only they are efficient in performance, but they're as easy to maintain. And later on, people can basically take your code and build on it. And these are the real concepts taught in the courses that are not necessarily there for regular programming courses.
I think what's also important, you touched on it slightly, but I want to hold on to that for a second, is that the program isn't taught in one language, right? Students aren't just going into one language. C++ is, of course, the majority of the world running right now. You're not teaching in COBOL or Fortran anymore, but students are going to be learning kind of the baseline of understanding how to work within any language. Would that be a correct statement?
That's right.
Yeah, Cyrus, maybe you can teach a COBOL course. I'm sure that'll be popular.
Yeah, I realized that you get very niche skill that they can use for programming unemployment checks.
Absolutely. Right. Cyrus, could we stay with you for a second? Can we talk a little bit about research in computer science? What's kind of the overall approach? What are some projects that are going on, and anything that you may know of a little bit more detail?
Sure. So currently at the department, we have 4 main areas that each area has its own kind of area leader, and these are research areas. So one is generally we call it AI, but it includes artificial intelligence, machine learning, privacy, fairness. All of these are basically under the AI area. The second area is called systems. That includes basically databases, networks, software engineering, so these are all under the systems area. The third one is theory, then basically includes, of course, most of our theory faculty working on the underlying fundamental research of computer science. And then the last area is robotics, computer vision, graphics, and HCI, human-computer interfaces. So as you see, across these 4 areas, we pretty much cover all research in the field of computer science. So we have faculty in all areas. Now, as far as the undergrads, actually, they can get involved with research as early as the freshman year. I actually, in my lab, I have 1 freshman undergrads working, and I know a lot of other labs they have, because as soon as somebody come in and take the 103, they're ready to help with some programming, and we can always get them incorporated in some of the research going on. Our best cases are usually people who start as a freshman and then stay with us with the same lab all the way until graduation, and those are the folks who usually try to apply for graduate studies and continue, for example, for PhD. So they get a lot of research experience while they're here.
Given what's going on in computer science and how entrenched it is in our daily lives, what do you all see as exciting developments, in the next 10 years? Things that are happening now, or things that you foresee happening?
I guess Jeff touched on that. So it looks like that currently, again, if you look at the field, I mean, right now it seems like it's always been like this, but it wasn't. Right now, for example, in mainstream media, you hear terms that are these are like the fields within computer science that nobody knew about them 10 years ago. You hear AI, ML, cybersecurity, robotics. None of these people knew what they were in 10 years ago. So it's becoming more and more mainstream, and I think this trend going to continue. People would see the impact of the computer science. As I mentioned, all these companies, major companies, basically both in US and internationally, are really computer science companies. And there would be more and more need for computer scientists, and more and more need for people who can code, even if they are not computer scientists. So that's why we started also a different program, the data science program, where we teach computer science to non-computer science students. Somebody is in chemistry or physics, they all also need computer science. So this integration of the field in everyday life, I think it will grow. And then the field itself had, throughout the years, many spikes that things suddenly turned. We have seen one of them in the past couple of years, which was the data-driven aspect of the work of the research, where we built these machine learning systems that consumes a lot of data, and suddenly it feels as if they are thinking. They are not. But because they've seen so many examples of real world data, they can basically mimic as if they are thinking, and they're creating new things. And that was one of the recent kind of major disruptions. And we had this throughout the years. In the past, we had it in robotics, for example. We had it in computer vision. And I'm sure going forward, we'll see more of this coming. And each one of them would pretty much create a whole new economy. And that's how it happened for the past several years. And I'm pretty sure it's going to continue happening going forward.
Yeah, to add to that, Cyrus mentioned anything that you see in the mainstream news. The news likes to pick up on these hot topics right now, like machine learning, artificial intelligence, data analytics, and those are definitely popular topics. But what they don't also show is how much work is still being done in so many other areas, web development and mobile app development. Most students will go out and get internships and jobs in one of those two areas. The majority of our students aren't going out getting AI jobs right now. Some, don't get me wrong, it's becoming more popular, but there are so many other jobs that students can go out and get also, that don't get caught up just in what the current buzzwords are that the media is showing. Talk to people who are familiar with the field and understand how much more demand is there in other areas as opposed to just these ones that are being discussed.
That's my favorite. It happens a lot with industry, and where students say, like, well, I want to go work for Google. I'm like, well, there are other companies that are doing a lot with computer science. Can you talk a little bit more about where you've seen students go to and the types of opportunities that they have? Because I think in that same regard, students look at it that, well, I'm going to go to computer science, so therefore I have the following options, Google, Microsoft, Apple, depending on their knowledge, they'll say Facebook or other types of the big Silicon Valley things. And it's so much more widespread. So let's address those topics with internships and full-time positions, and also where you see your students go.
So they all go to Google.
I shouldn't say that. They all do. That's true. But there are. I wasn't expecting that. That was awesome.
They all get hired by Facebook, Google, Microsoft. but yeah. We're one of the big 4 feeder schools for all the jobs in Silicon Valley, for better or for worse.
Yeah, that's right. So there was this. It's now 2-year-old, but there was this study that they did on counting the number of alumni from different universities and which one are the top going to Silicon Valley, and USC was number 4. I have it somewhere here. I can tell you what were the first 3. I think it was Stanford, CMU, and Berkeley, and then number 4 was USC.
I also have a lot of other students I see getting hired by the big like aerospace people who do tons of software systems, Salesforce, Snapchat. I mean, we have a big, like here in LA, there's a lot of big tech companies. They either have their headquarters or their extension office, and so I feel like a lot of those kind of names like Snapchat, Salesforce. All the names escape me. I can see all their logos flashing in front of my eyes, but they also take a significant amount of our undergraduate students as well.
Northrop Grumman, Lockheed Martin, SpaceX,
Oh
Boeing,
yeah,
Raytheon.
yeah.
Right. And there are also game companies.
Yeah.
Blizzard is here in Orange County, for example. They hire actually a lot of our students.
Yeah, EA, Blizzard, some of the more movie studios and production companies as they go into games as well. Can we talk a little bit about the games curriculum? Because we have some students here that have been admitted to that, and how that differs from the traditional computer science programs.
Sure. They're going to start off though with more or less the same core of computer science as the other computer science majors. So they're going through the 102, 103, 104, 170. It's not till you get to the end of the second year or the third year. I mean, intermixed in those first 2 years, they're also taking some of the basic cinema games classes as well, like game design, fundamentals of game design. It's not until you get into the end of the second year, the third year, and the fourth year, we're going to see a big divergence. And then they're taking a lot of, for example, the advanced game projects class. They're learning how to program the different kinds of game engines, for example, like Unreal and Unity, learning how to set up games in those. And also taking classes in the cinema school that focus more on the what's the right word for this?
Like game design.
Yeah, how you actually design games to make them playable, intriguing, set up nice story scenes and scapes as you go through that.
The cinematic elements.
Yeah, thank you. That's the right word.
Right. I think there are three aspects to games in general. I mean, there's definitely the CS and technical aspect, there's the artistic aspect, and there's the production aspect, which is like a producer of a movie, basically, that goes to that. So they'll take a combination of all these three types of courses. And mainly, I would say the main difference between game and our general CS is that the students would end up with less electives. Because most of those electives would end up to be required cinema school courses that they need to take.
Absolutely. Cinema, I think it was a fine arts course as well, but it's that combination of the technical and the artistic, which I think is a really unique opportunity.
That's right.
We've kind of touched on this a little bit, but I want to ask a specific question about the balance of theoretical work and hands-on work. And I think that there's kind of a nice culmination into Jeff's capstone class, which I'd like him to explain a little bit more in detail. But can we start to explain theory versus hands-on, and then maybe end with Jeff on the capstone?
Sure. The intro sequence is set up to kind of have a hand-in-hand matching of courses. So students are starting off the very basic programming class is 102. We consider that the more hands-on programming. At about the time they move into the next one, which is 103, this is a more standard introduction to programming class. They're also starting up 170, which is the introduction to a lot of the mathematical and theoretical underpinnings of computer science. So it's starting to look at different kinds of algorithms. And then they move into 104, which is a mixture of hands-on programming, but also starting to look at data structures, different kinds of trees and hash maps, also different kinds of sorting algorithms that they may have to build. And there's at the same time, I mentioned that the 170 class, which is the basic algorithm class they're looking, and then they're moving into the 270, which is more advanced algorithms. They're learning about complexity theory. They're doing reductions from NP-hard problems, SAT problems, and also just learning about some of the other kinds of algorithms that exist in computer science. And then they move into 201, which is the class that Jeff typically teaches. So the more advanced programming class, we're learning a lot of very practical things about building applications, web applications, also doing threading, which is a very common type of programming technique that is used as well. And then at that point, they start taking things like 310, which is a very practical oriented how we build software systems in groups, before finally transitioning into the capstone, Jeff's class.
So for the capstone class, it's a class that As I said, all computer science students need to take. And in the class, what we do is I have a number of projects each semester that are run by outside stakeholders. So for most of the curriculum, what you've gone through in the classes that GJ just mentioned, these are all assignments are given to you by the faculty members in the class, and that's what you complete. Well, it's preparing you so that hopefully you can then take a project description from a company or an organization and then turn it into a software product. So in the capstone class, I don't assign any of the projects myself. I have a number of different contexts. We support anywhere from 30 to 50 projects a semester. And there's outside stakeholders who write up a description of this is what I want done. And that then gets selected by a team of students in the class. And you work with that outside person to complete the project. Now, this class is taken in one of your last 2 semesters before graduating because you need a solid foundation in all of the computer science topics that we've discussed and that you've learned up to that point, because this is really the last step before we're turning you over to the world and saying, putting our stamp of approval on you and saying, you are now able to be a productive computer scientist in the world. And this is your chance that you're still under the umbrella of the university, meeting with me and the TA every week so that we can help you through any of the technical problems or any of the soft skill problems that you're going to have communicating with your stakeholder, communicating with the other people on your team before we finally turn you over and you get hired by a company and you're working on your own as opposed to under the university's umbrella. So it's a great class. It's one that a lot of our companies that hire our students specifically cite even and say it's a great experience that students have already had some practical hands-on experience programming with a company or an outside stakeholder before graduating, which is not always the case with other universities.
And if I could add my comments, as one of those stakeholders that I've participated in this class in the past, I've had at least 3 or 4 usable software solutions specifically for undergraduate admission at USC, specifically because of Jeff's class. And it's always fantastic to work with our students because it's interesting to see their progression as they are working from that academic background into a company that delivers, for lack of a better term. That's an educational process that is challenging to take on when you just are just taking classes. It's a nice transition to the workplace, which is fun to work on. So I'd like to actually pause for a minute and get back into your guys' personal histories. These high school students are about to leave high school and about to enter this world of higher education. They have fantastic options wherever they're going to go, and they have some choices to make. You all have been through this, and I always like to make sure that students know that everybody's had different backgrounds. We touched on this a little bit with your intros, but where did you go through your coursework, undergrad through PhD, and how did you end up at USC? I know, Jeff, you went all the way through, right, at USC?
I did, yeah. I came into USC. I was a computer engineering undergrad, and then I liked the software better than the hardware. So then I did my master's and PhD, both in computer science. And my choice to stay at USC is just because I had such an amazing experience as an undergrad. And I loved being there. And as soon as we all get back together and you can hear the marching band play and you can go to a football game, you guys will all, want to come to USC anyways. Paul, are you having like a video of the band play for everyone here?
Not a bad idea. We'll have to figure that one out. Yeah. I can share also. So it sounds like an exception, but it seems like that at least in this crowd, that's not an exception. I also did my master and PhD at USC. My undergrad, I did it in Iran. I went to Sharif University there. And things there were very different. Basically, you just, there was one single national exam that you take, and then you decide based on your rank which universities you want to go to. And then some universities had basically more difficult to get into, therefore you needed to be a higher rank. So it was almost like a matching game, not necessarily a decision of where you want to go. So I think people here are actually lucky that they have that opportunity to make a decision among many good schools, which one to go, USC included. Now, for USC specifically, I want to mention one thing, and that's basically the background picture that I've been using. So this is where I'm sitting is actually a parking lot, and that parking lot gonna change into a new computer science building. So we already have the donor, and the everything is approved by the board of trustee and president. And even during this difficult times of the pandemic, we heard that the project's still going on. So hopefully in 2-3 years, we're going to have our new computer science building here. And that's basically 100,000 square feet of space, just so that, currently our space is 50,000 square feet. So this 50,000, so this would double our space, and it would have a lot of nice settings for our undergrad students. So that's one, I guess, reason to pick USC. You're going to be starting in maybe not the first year, but at least from your junior year, at least, if not sooner, you'll experience a brand new building with a lot of nice lab spaces to collaborate. Now, from a personal perspective, as you mentioned, so that I guess the reason I said this should be an exception is because usually we don't hire our own, and I usually make this joke because I'm the only one, but now we have Jeff, so I should be careful. But the reason I say usually I ended up staying at USC is that there's only very exceptional cases that we hire our own. And one of those exceptions is that if the person is really so bad that we don't want this person to go out and ruin the reputation of the department, we try to contain this person and keep that person inside USC. And then as soon as they have competitive offers from outside, we just give them raises and or promote them so they keep staying. So that's how I ended up becoming a professor at USC. That's why I'm the chair. I mean, it's downhill after this.
I mean, Cyrus says that, but what's really funny about that is that the other computer science faculty who have gotten their PhDs here, one of them is now our executive vice dean. Cyrus took over the chair position from him, and the other one just retired as a distinguished professor. So we're with good company there, but whatever the reason is, Cyrus, just keep giving me those raises and I'm good.
GJ, your background?
Oh yeah, so I was one of those kids who, from I don't know, so early age, I knew I wanted to do computers. I thought it was the coolest thing ever. I was programming in my parents' basement, so I'm one of those. And then I went to like a tech school. It was a high school, and then I went to the University of Virginia for my undergraduate. I grew up in Virginia. It was my state school, so it was financially the best choice for me. And then I did my PhD at Georgia Tech because there was a couple people there that I wanted to do my focus on, particularly in software engineering. And then when I got offered the job at USC, it was kind of a dream job. I really wanted to be in a big city, and LA is one of those places that just had so much in it. And it came out. That was 2010. It was I took off. I was staying with my parents before I started. So I got on the plane in early morning. It was 27 degrees in Virginia at that point, and I landed, and it was 75 in Los Angeles. And I've just really liked being here at this university, and also here in Los Angeles since then.
Absolutely, the weather always does play a factor. So I'm going to open it up to our audience for questions. So if you have questions, go ahead and type them into that chat box. Use the chat function. I'm going to moderate those questions. We're going to get to as many questions as we possibly can, but feel free to ask your questions into the chat box. And sometimes questions are, similar or kind of different wording of the same question. So oftentimes I'll just wait a little bit and kind of combine some things. So I'll be hopping around. One thing that we have yet to touch on, and hopefully we can get a little more detail on, is this computer engineering, computer science degree program. So housed both within computer science and the electrical and computer engineering department. It's a software hardware combo. Can we describe it a little bit more and how that program differs from a traditional computer science degree?
Yeah, it really starts to, again, we have the same, in a very similar core part of the program in that first year and a half with the 103, 104, 170, 201, where you really start to see the differentiations is that when those electives are the options that students have for the electives, you can see that the set of electives that students can choose from for the regular CS major versus the CCS major is different. A little less of the more software systems or programming courses, a little bit more of the EE oriented courses, looking at the hardware aspects, the computer architecture type of classes as well. So you're going to see a bigger mix in the electives. This is where you really see the primary difference.
Great. And then the first question that came out is the last program that we've yet to discuss, which is Computer Science Business Administration, exactly where I was going to go. So this is a unique combo combining courses from the Marshall School of Business into a computer science degree program.
Yeah, you're going to see the same thing. So, it's kind of the same story that in the beginning they have a very similar core. What starts to happen at the end of the second year and third year and fourth year is that the elective pool is very different. CS majors are not required to take accounting, but CSBA majors are. And so you're going to start to see them also have to include a certain subset of electives that's going to draw from marketing, online marketing, the accounting techniques, strategic management techniques as well. So from those classes, they're going to be taking electives whereas like a CS major would primarily be taking classes that are computer systems, operating systems, networks, machine learning, those kinds of courses.
Absolutely. Can we talk? We touched on it slightly, but I wanted to address a little bit more the idea of internships available to students. First, you should understand that we have a school-wide career connections office focused on working only with engineering and computer science students, which is in addition to what the university does, and bringing hundreds and hundreds of employers onto campus to not only network with you, but engage and recruit you for those internships. And it is more and more common these days that students are getting internships as early as the summer after their first year. But of course, your opportunities increase the more classes that you take as you go throughout those as you go through those courses. So recognize that internships are definitely available, and students are recruited all the way through their time. Where we have our engineering opportunities specifically with networking events, and like we said, we do interviews, but we also have our fall engineering career fair and our spring engineering career fair that happens, and students are very successful in that. There's a question here about, and I'm going to punt it to you guys, but we kind of already talked about this, but someone's asking to either they missed the question or they want to talk about it more, the opportunities for research in computer science and opportunities for undergrads.
So I mentioned that. So basically, there are multiple mechanisms to get involved with research. So basically, we do have our kind of merit scholarship, basically, where the students get paid. Actually, I think, if I'm not mistaken, it's $2,500 per semester to work at research labs. So those who get this merit fellowship at the school level, they basically can reach out to faculty directly. There are also websites that the various projects are listed at various labs, and they can select and go to that one. So that's one method. There's another mechanism. Actually, GJ might be able to present that better, because there's a kind of a fair that we put together where the PhD students present their posters, faculty and postdocs show up as well, and the undergrads can go around and talk to the PhD students and the faculty and decide if they're interested in certain research, they can join. There's also opportunity that separately at this university level, there is this URAP, I guess, opportunity where the faculty can apply for funding to support undergrads, and then outside, like National Science Foundation has research education for undergrad supplement grants that again faculty will apply. They get the funding and they need to hire undergrad students to basically work on various research projects. So in a sense, there are enough financial incentive for faculty to make sure that undergrads are involved with the research, and there are a lot of websites that they put their information up, and there are a lot of forums that the undergrads can participate. I also want to mention a little bit about the internship and take this opportunity to also introduce our industry affiliate program. So our computer science department has its own industry affiliate program. Currently, we have Microsoft, Google, Facebook, DD, and others as members of this program. And they basically have various events for the students and at the undergrad level that the students can attend and mingle and interact with these the company's representatives, and these are all opportunities for getting internship. There was a question about freshman internship. That our observation currently is that some of the companies, like top companies like Google, Facebook, and so on, it might be tougher to get in as an internship as a freshman. But there are opportunities for internship for freshmen as a whole.
Thank you. Next up, I wanted to kind of get into this idea. First, we have some spring and mid students in here. You won't be behind. Just follow the things that we're telling you to do for the fall semester. You'll be good to go and still be able to graduate with your class on time. Can we talk a little bit more about the Center for Artificial Intelligence and Society? And how that kind of plays in. I know that's a specific research center, and also there's a student organization focused on that.
Yeah, so that center, CAIS, is the same as other centers that we have, which basically the method to get involved is the same that I mentioned for the research level. But I know that they separately have a undergrad student organization that also you can just become a member of that organization and get involved.
I was just going to add on that, the CIS, and in fact, those instructors do teach undergraduate level classes at the 400 level. So you're able to go and actually, the professors who are involved in that center also do project-based classes that are available for the undergraduates to enroll in and do things like applying AI to social problems.
Great. And then there's some questions that are really interesting because there's some specific things about curriculum and this class and that class. And then the one that just came up right now, is there a way to see the detailed curriculum? We mailed it to you. And so all of our admitted students, you were mailed our undergraduate handbook, and it has the 4-year plans for exactly the course outline of all the degree programs within computer science, in addition to all the other engineering programs. And we weren't able to get that. The mail may not have gotten to international students. And so if you're an international student, we emailed it to you. And if you haven't seen that, you can go to our website, viterbiadmission.usc.edu/CS. You'll see the complete degree programs for all of our computer science options. You can see exactly how the degree plans laid out. And then there is a question earlier about, can CS games minor? Now, yes, but there are a lot of courses already added into that program. In essence, you're already combining programs into that degree program. It is possible that students can minor on top of that, but it's going to be in a very individual case-by-case basis on exactly how much credit you're bringing in and how much work you want to do. This has come up in a lot of our other faculty roundtables. Minors are not something with a true yes or no question, because it always depends on exactly your major, exactly your minor, and exactly when you start it. Minors are anywhere from 4 to 8 courses, 16 to 32 units. Those are all different efforts. And so the real question is, do you want to do more work? And we don't know the answer to that yet until you start taking courses. Some of you are in high school are always going to say, yes, I want to do 3 minors and I want to do a second bachelor's degree. And I always say, of course you can, and we will gladly accept tuition checks from you for as long as you want to be enrolled. But the opportunities of how you want to fit that in are likely going to mean you're going to make some choices, and you're not able to make that decision at least until you start taking courses in your first semester. So let's see how that goes, and then see what you want to add on. And a lot of things you're discounting are how you're going to be spending time outside of class. College is not just taking classes. That's a big part of it, but you're going to be doing a lot of other activities, and even within student organizations, design teams, etc., that will still have academic bents to them. Can you all talk a little bit more about entrepreneurial opportunities, maybe students that you've had involved in those, and where you've seen kind of CS support those elements? Startup Garage has come up in our chat, but also the MSc Entrepreneurship Prize Competition, Min Family Challenge.
Sure. So basically, I mean, you already mentioned there are a number of competitions that the undergrads can compete actually with. And some of these competition, I don't know if this one is still going on or not with the Stevens Institute, but the competition itself also provides some support in the sense of kind of pairing you with students from business school who can help with your business plans, for example. Also, some of them assign you a mentor who is a serial entrepreneur who basically advise you through the process of competition. And at the end, if you win the competition, there are different size for different prizes. I think MSc prize is $50,000, if I'm not mistaken. And the Stevens was at when it was running, it was $100,000. So you get various types of financial support at the end that you can invest that in the company. As far as the ideas, actually, it's, courses like what Jeff described, the capstone and GJ's courses, those are the type of courses where ideas going to come out, and you can basically, if you're interested, you can go that path. Personally, actually, I was involved with two companies. I was founder of two startups, and both got acquired, one in 2008 and one 2019, actually. Sorry, 2012 and 2019. So there are a lot of faculty involved with entrepreneurship. The students can also join the faculty research, and if they see an opportunity, they can go for startups from there.
Absolutely. And I think what's important to understand is that this process is something that happens as you go. And as with everything in engineering, it's somewhat of an experiential process. As you start going through courses, you start meeting teammates, you start coming up with ideas, you're involved in student organizations. Maybe you're like, oh, hey, this startup garage or this entrepreneurial competition has an application period, and we have this idea, and so we're going to enter into it. And so it really becomes very organic, but also it takes students to have that drive and interest to do those things. Is this something you're going to jump into and be a startup garage participant in your first year? That's highly unlikely because you're also competing against other students at the institution. But those ideas become curated and cultivated over your time. And so realize that that's something that's waiting for you. And what I've seen over our programs over the last 10, 15 years is we've done nothing but increase opportunities towards entrepreneurial efforts and innovation. Here's going to be a fun fight. Mac versus PC. What should the students get? I love to see this happen. This is going to be fun.
Laptop, I say Mac, but that's changing though.
Okay. You said Mac?
I say you use whatever you're most comfortable using. I would say the majority of my students do have Macs, but there are still a number of them that have Windows. Personally, I'm a Windows user, but kind of a personal preference. Either one of them is not going to prohibit you from completing the program.
I agree. Neither one's going to hold you behind. I'm a PC user, Windows user, and every time I see a Mac person walk in, try to give a talk or do something like that, I'm like, did you remember your dongle? Where's your extended desktop? And they always have a hard time getting everything. And with the Windows, everything just works, and you can stop worrying about that and just focus on the key stuff that you want to deal with. You don't have to go and worry about all these special cases, exceptions, and things like that.
I love this fight because students always think we have like one answer, like there's an answer for this. And it's like, no. And you can survey faculty, you can survey students, and it's all pretty much 50-50 across the board. And what's funny about this most, GJ, is that's my answer for Mac all the time. Whenever I plug in my Mac, everything's working fine. Whenever a PC user or a Windows user is trying to log in to do a presentation, there's always issues with resolution. So I can go tit for tat on all these things. But I'm incredibly biased. I live in the Mac world. I'm staring at 5 devices right now that are all Apple. All right, and then this is going to be our last question as we start to wrap up here. And it was very nicely put by Melissa, and I was going to do a similar question, so thank you, Melissa. What aspects of the USC Computer Science Department distinguish itself from other top engineering programs at schools such as Berkeley, Stanford, Georgia Tech, Carnegie Mellon? I mean, obviously our students admitted all these programs and are trying to make this decision. There's some key things I'll point out right at the forefront. Size. Large public institution versus a smaller institution. We're only going to have 410 engineering students this fall across the entire engineering school. And so the opportunities for ratios are important, but I'll let you guys talk about our program compared to those.
So the first thing that I think, especially for undergrad students, I'm sure GJ and Cyrus will jump in with some of the other aspects, but something that I see with undergraduate students is our class size. That if you want to look at some of the other top computer science programs around the country, you're going to see that their intro to programming classes could be, and this is not even an exaggeration, it could be hundreds or even into the thousands of students that are taking that class. Our classes, we offer multiple sections of each of our classes so that we can limit the class size of them. Of course, computer science is an in-demand field, so we don't have class sizes that intro ones down to 10 students, let's say, but we do keep them at a manageable number, somewhere in the 60 to 80 range, somewhere like that is what we try to keep our intro classes. And as you get up to your 300 and 400 level classes, that might drop even more. So that's something I see that touches undergraduate students directly is you're able to actually talk to your professor. I have office hours of students come in and talk to me. And if I was teaching 1,000-person class, it wouldn't be feasible to have that. So you can actually get to know your professors.
That was great. Other thoughts?
Yeah, I think to echo what Cyrus says, these are all great schools with fantastic faculty and high rankings. One of the things I think is very unique, having been, just at the UVA and Georgia Tech and now here at USC, is the amount of resources that are poured back into the teaching. So, for example, I teach 310, and I have a class of about 90 students. I have 13 staff for that class. So 10 of them are undergraduate CPs who run about 10 hours worth of office hours per week, and then my 3 teaching assistants as well. And the really nice thing is that we're able to respond to requests faster. We're able to, if somebody's having a problem, I can send them to one of my CPs, and they can sit down there and look at the laptop and help them, figure out what the problem is going. And it's not just me by myself, trying to manage and respond to this really large class. There's a lot of support, which means that there's more opportunities for the students to get help as they're trying to figure out these courses.
Yeah, I mean, there are a couple of other things besides what you guys already mentioned about the size and so on. I think one important aspect of USC is the alumni network. I think USC has one of the strongest alumni network, and they can help whether you want to start your company after graduation, whether you want to start working at top companies. Most of my, for example, PhD students are now managers at Google and Snapchat and so on, VPs and so on. And many of my just undergrads, for example, working in my lab have direct access to them. And they really care. I mean, the fact that you're a graduate from USC immediately puts you top of the list of basically getting attention from these alumni, successful ones. The other aspect that I want to also emphasize, I guess, is this personal attention. I guess there's part of this, which is the university, the faculty and research and all that, but there's also the staff like Paul. The level of personal attention I see our undergrad students get from various staff, both within the school and university, is way beyond what. And I went through this because my son is actually a freshman, and we went through various universities, and we ended up deciding on USC, in fact. When we were looking at these other universities, going through these tours and introduction, that was not the level of attention. Unfortunately, we can't do this year because of the online situation, but we're doing the best we can given the situation. But that's another aspect of it. And then, of course, the research involvement. We have various institutes affiliated with our department, like Information Sciences Institute, Institute of Creative Technology. We also have the Top Game program. It's been #1 many years back to back. So all these, I would say, other reasons that distinguishes USC from the peers. But again, I mean, those the CMU, Berkeley, those are all top schools. You can't go wrong. It's just at the end of the day a matter of decision that which one you feel more comfortable and think that is more for you.
Thank you for that. I think that's a great way to wrap this up, and also to help kind of add some context. I don't know of another school where we can actually engage and send an email to the faculty and say, hey, can we do this? And you guys jump right on this. And your willingness to engage with prospective students and to talk about how much you care about our program, how much you care about our students makes a huge difference. So it's always been a pleasure working with you. It's a pleasure being able to share this time with each of you as well. So thank you very much, Dr. Miller, Dr. Halfond, and Dr. Shahabi, for representing the computer science department. For all of our students that are here, again, congratulations. I know you have a tough choice, but as they've mentioned, you can't make a wrong one. We do believe that you belong with us. We really hope that you're going to be able to choose us. If you haven't had a chance to attend our Viterbi keynote sessions, which go over the school and the resources available to engineering students, regardless of discipline, those run on Tuesdays. We have 2 left. If you haven't registered for that, you can do that at your admission portal. And if you haven't made your decision to join us yet, make sure you do that by May 1st. That's at your admission portal. It's admission.usc.edu/status. I'm going to sign off here. When I do that, that'll close out everybody. So faculty, again, thank you so much for this time. I really appreciate it. Thank you very much, everybody. Fight on and have a fantastic day.